Hey everybody, welcome back to Curator on the Loose. It's been a while since we've been here, but it will be worth the wait, I promise. Why? Because today we are checking out one of the most popular planes in our museum. Oh, I know what you're thinking. Yes, the SR-71, baby. Well, not quite. We're talking about the M-21, which is not an SR-71, but rather a modified A12. How cool is that? Lockheed Built the A12 is a high-altitude Mach 3+ reconnaissance aircraft for the CIA, and it was the 12th design from Clarence Kelly Johnson's design team, which led to its eventual A12 designation. In 1959, it was selected over Convair's Fish and Kingfish designs as the winner of Project Gusto. And then it was developed and operated under Project Oxcart. The CIA liked Convair's design because it had a smaller radar cross-section, but the A12 had slightly better specs and its production costs were lower, so it won out. Not every low bid is bad, right? Lockheed had also established a great track record with its U-2, which had come in on time and under budget, while Convair's B-58 Hustler had been plagued with delays and cost overruns. Plus, Lockheed already had experience running black projects. The A-12 was produced from 1962 to 1964 and was the precursor to the Air Force's twin-seat YF-12 Interceptor, the CIA's M-21 mothership for the D-21 drone, and the SR-71 Blackbird. The original intent was for the A-12 to replace Lockheed's U-2 that was flying reconnaissance missions over the Soviet Union and Cuba, but it never actually flew over either country. After Francis Gary Powers' U-2 was shot down over the USSR in May of 1960, President Eisenhower publicly pledged that the United States would no longer fly crewed missions over the Soviet Union. The key word there is crewed, but we'll get back to that later. During the Vietnam War, the CIA deployed 3 A-12s to Asia for Operation Black Shield. The aircraft from the 1129th Special Activities Squadron, a joint USAF-CIA squadron, arrived at Kadena Air Base on Okinawa in May of '67. The unit's first mission was over North Vietnam to photograph SAM sites in the DMZ. The mission lasted just 3.5 hours because it was flown at Mach 3.1. That's 2,378 miles per hour, in case you wanted to know, and at over 80,000 feet. From May '67 to June of '68, the A-12s of the 1129th flew 29 sorties over Vietnam, Cambodia, and North Korea. Sadly, right before the 3 aircraft departed for the U.S., pilot Jack Weeks suffered a catastrophic engine failure on a check flight and disappeared somewhere near the Philippines. No trace of him or the airplane has ever been found. A few weeks after Black Shield ended, all 5 surviving pilots received the CIA's Intelligence Star for Valor, but the program remained classified until 1991, and some of its details are still classified. The 7 remaining A-12s are scattered across the United States on public display. One even stands watch over the CIA headquarters in Langley, Virginia. How cool is that?
I got tremendous satisfaction over having had the ability to master these systems and work in such close crew coordination with a pilot like I had never done on any other airplane, the pilot of which had his own very unique set of controls and ways of powering and flying in that airplane. To see that all come together and to do it in a mission of national importance, that kind of job satisfaction is hard to come by.
That was a Cold War period when we were both flying. I was 81 to 85. John was just after that. And knowing that in a peacetime environment, if you can call the Cold War a peacetime environment, we were going out and getting a product that was needed at the national level on every operational sortie that we flew. So a great deal of satisfaction in knowing you were getting something the country needed.
So what made the A12 so awesome besides its amazing top speed? Well, for one thing, what it was made of. This baby was made of huge amounts of titanium. Because the A12 was well ahead of its time, many new technologies had to be invented specifically for the Ox Cart project. And one of the biggest problems that faced engineers was working with the titanium used in the construction of this bird. Titanium is hard and difficult to machine, which made it hard to form into curves with the available tools and techniques of the early 1960s. Before the A12, titanium was used only in high-temperature exhaust fairings and other small parts directly related to high-temp areas on an aircraft, including the leading edges of the wing. Since it was so difficult to work with, Lockheed machined small triangular fillets out of titanium and then glued them onto an underlying framework. Check out the leading edge of the wing. See the triangles? The wing's framework of spars and stringers formed a grid, leaving triangular notches along the edge filled with an alternating pattern of beta 120 titanium and composite. The composite material was an iron ferrite and silicon laminate combined with asbestos to help absorb radar signals. In fact, large section of the trailing edges, vertical stabs, and chines were made of that composite. So where else was titanium used in the A12? Well, pretty much everywhere. Heck, 93% of its structural weight was from the titanium. All those panels you see above me are titanium, and the metal gave the Lockheed workers fits. Only about 17 holes could be drilled in each panel before the drill bit was trashed, and the worker had to grab a new one. However, by the end of the SR-71 program, bits developed by the Skunk Works crew could drill 100 holes and be resharpened for further use. During welding, rare and expensive argon shielding gas was used to eliminate oxygen from the metal to get the highest quality welds. That's amazing stuff. And what about this paint scheme? What's up with that? It looks cool. Heck yeah, it does. But it also has a job to do. The Blackbirds earned their nickname because they were coated with a high emissivity black paint for improved heat radiation, thus reducing the thermal stresses on the airframe. In other words, the paint helped remove heat from the plane as it flew. While the first A12 initially flew unpainted, later models were painted black only along the periphery of the airframe, where heating was the greatest, like the leading and trailing edges, the rudders and the chines. Now the chines are those funky sloped surfaces at the edge of the fuselage, which blend the fuselage into the wings and help it generate lift and diffract radar waves. Awesome!
The program is quite unique, and both the front seater and the back seater, the pilot and the reconnaissance systems officer, had each his own course of study, but did it together as a crew. So what was different about this program? Two main things. First of all, the only people coming into the program were highly experienced, like Les just mentioned. I think the pilots had to have 1,500 hours of time in other aircraft, and we in the back seat had to have at least 1,200 hours. So that would equate to several years of flying. So we were captains and or majors in the Air Force by the time we could even qualify to apply for it. And then the second thing that was quite different than any airplane I had been in before is that we spent a good 5 to 6 months in a simulator before they'd actually let us get into the airplane. That's completely unorthodox compared to most airplanes. Usually you're in simulators, but you get in the airplanes pretty quickly. We had to prove ourselves capable, very capable, before they let us in the actual airplane.
And just to piggyback on John's remarks, the reason for that was the tremendous amount of coordination that was required between the two separate cockpits in the airplane. If you weren't on the same page, reading the same checklist, thinking about the same checklist, eyes on the mission, that sort of thing, then you were going to be in a heap of trouble. And that took a lot of simulator time. And I can't remember the exact hours, but John said 6 months, which is about right. And that probably equated to roughly 100 hours of simulator time, which is way more than I ever spent in any other jet.
Okay, back to Lockheed's struggles with titanium. If trying to drill this stuff wasn't bad enough, the landing gear struts were milled from one solid block of titanium, which was the largest titanium forging in the world. Check that out. That whole piece is one solid chunk of titanium. That's nuts. But what's even more nuts is where we got the titanium sponge used to build these birds. We didn't get it from the US, Great Britain, or any of our allies. Oh no, we got it from the Soviets. The CIA set up cutouts, which is spy talk for a sham company, and they purchased the titanium sponge on behalf of the Titanium Metals Corporation. Once we got the sponge, we turned it into whatever type of titanium we needed. The Soviets never even knew they were helping us build an ox cart. And while we're right here, what gives with the silver tires? Well, when your aircraft skin can hit nearly 1,000 degrees Fahrenheit, you need a rubber tire that won't blow up in your wheel well. B.F. Goodrich developed a rubber compound that was infused with aluminum powder so the tire would not degrade during flight. They were also filled with 415 pounds of nitrogen instead of air. Nitrogen is more stable than air at different temperatures, and you want your tires to be at the right pressure when you're screaming down the runway for a landing at about 175 miles an hour. Oh, and one last thing about the tires. They cost $2,300 a piece, and we're good for about 15 to 20 landings. Let's see, that's about $9,200 to equip my Outback, but it would look so cool. All right, we're now at the front landing gear, and I know what you guys are thinking. You're thinking, what's with the non-silver tires, dude? Well, that's because they didn't need silver tires in the front landing gear. You know why? Because these babies got a C. Well, they really didn't get a C, but they just happened to be right where the AC dumped out of the aircraft, so they were cooled on their own. No need for silver with that. All right, I know this is what you guys have been waiting for, the J58 engines. Let's talk speed. Now, the A12's power came from the combination of the inlet, the engine, and the exhaust functioning as a single unit. For example, cruising at a leisurely Mach 3.2, only 18% of a J58's thrust came from the engine proper, while 58% of the thrust came from the inlet. In other words, at cruising speed, the engines functioned merely as flow inducers, creating the low pressure that enticed air to enter the inlets. To oversimplify it, the A12 sucked its way through the upper atmosphere. It's weird, but it's true. But why was it so fast? Easy. It was designed that way. The J-58 was an afterburning turbojet that incorporated a unique compressor bleed bypass at high Mach numbers. When opened, the bypass valves bled air from the fourth compressor stage, and 6 ducts routed around the compressor rear stages, the combustor, and the turbine. The bleed air re-entered the turbine exhaust around the front of the afterburner, where it was used to increase thrust and cooling. The whole process kicked in at about Mach 1.6, and the percentage of bypass air increased up to Mach 2.8, when the bypass valves were fully open and no air was going through the last 6 compressor stages at all. Because of its wide speed range, the J-58 engine needed 2 modes of operation. 1, to take it stationary on the ground, and 2, to take it to nearly 2,000 miles per hour at 70 to 80,000 feet. In essence, it was a conventional afterburning turbojet for takeoff and acceleration, but at Mach 1.6, it used the compressor bleed to the afterburner for that extra kick. The way it worked at Mach 2.8 and above led it to be described as a turbo ramjet.
Actually quite comfortable in the cockpit, and the cockpit was pressurized normally to, as I remember, John, 34,000 feet, or some number close to that.
Yeah, about 25,000 or so.
Yeah, but you knew that the heat was there because you could take a tube of pureed fruit or something that you wanted to heat, merely hold it against the cockpit windscreen and have it heat up to a comfortable temperature in just a few seconds. So the heat was there. It was just fortunately taken care of by the air conditioning and pressurization system.
So we had 2 things going for us there. First of all, they had to solve the problem with the cockpit itself getting too hot. So the air conditioning system in the airplane brought the temperature down inside the cockpit to something tolerable. And then our suits were, like any pressure suit would be, ventilated with cooling air as well. So you had nice, cool air, dry air circulating within the suit. So, but I do recall, even with 3 or 4 layers in our gloves, you could put your back of your hand up against the cockpit, the window, and feel it. It wouldn't take long before you start feeling the heat, because it's running about 500 degrees Fahrenheit or so on the exterior of the airplane around the cockpit.
And that's one of the cooler sections.
Yeah, that's one of the cooler parts of the airplane. Being in the cockpit of that airplane was not unlike being in almost any other cockpit of an airplane. It was that well controlled, so your sensations were similar. Visually, a different matter. You could see things, and your brain would process things and realize just how high, and your mind would tell you how fast you're moving just by the fact how much geography you're covering. But I do recall in the evenings when we do night flights, we usually refuel right around sunset, and then the profile called for lighting the afterburners and starting your climb to high altitude. And it was a beautiful sight, though. In the evening, you could see the blue plume of the exhaust of the engines looking down these little mirrors we had. You could actually see it blossoming out behind the airplane, and blue gives you indication just how hot things are running back there. So you had some of those clues, but otherwise it was your brain telling you what was going on. Sitting there, it was quite comfortable.
This Hoss is the AG330 start cart for the big J-58 engines. It looks pretty boring, right? Well, looks ain't everything. Under the hood of this thing are not 1, but 2 Buick 401 cubic inch V8 Wildcat engines that developed 400 horses each. The AG330, also called the Buick, had the Wildcat engines mounted side by side with automatic transmissions. They were coupled together by a woven steel drive belt to a vertical drive shaft that was inserted into a starter port on the bottom of the fuselage and right into the J-58 engine. On engine start, there was 1 Buick for each side of the plane. When these things kicked off, it was like being in the pits at Daytona. For one thing, there were no mufflers on the Wildcat engines. And as the throttles were spun up, Flames almost 3 feet long erupted out the side of the cart from the 8 exhausts. Combine that with the sound of the J-58 spooling up to 3,200 RPM, and you got a real show. This coupler is what harnessed all the Buick's monster power and transferred it to the J-58 engine. The ground crew hoisted this entire piece up into a port underneath the engine and in the fuselage and hooked it into place. The telescoping shaft pivoted up to 1/2 inch to account for slight variations in the cart's location below the plane. The probe, it had 2 handles right here that contained switches. The top switch brought it up, the bottom switch lowered it down. Now it looks like it's a long way to reach, but remember, our plane is on stands. In reality, the shaft only had to extend about 8 to 10 inches for a fully loaded SR-71. And the starter coupler is only about 1 inch or 2 inside the aircraft's fuselage. That's pretty simple. Once the Buick was all hooked up and ready to go, the pilot told the crew chief via intercom, "Engage Buicks." The operator pressed jet start and moved the throttle down to run. One throttle controls both of the engines in the Buick. That engaged the transmissions and began to throttle up those big Wildcats. The Buick operator had to accelerate but maintain 700 to 725 pound-feet of torque during start. Too high a torque would cause the shaft to drop out, which could overstress the Buick's gearbox. Too low a torque could cause a lag in acceleration to idle speed in the J-58 and create an over-temperature condition. As the Buick spooled up the J-58, the pilot watched his onboard gauges to confirm minimum oil pressure, fuel pressure, and rising RPM. And then he set the throttle to idle. At that point, 30 cc's of triethylborane, or TEB, was injected into the combustor. TEB ignites spontaneously with oxygen, and it kicked off the engine's ignition by lighting the JP7 fuel, which had such a high flash point that it would not ignite by conventional means. At that point, a green flame erupted out of the burner cans and the engine began to run on its own. Once it hit 3,200 RPM, the pilot called "Buick's out," and the crew chief signal cut to the Buick operator, who hit cart shutdown, and the shaft just kind of fell out of the engine and back into the stowed position. That's pretty easy, I guess. In the mid-1970s, the Wildcat engines were changed to Chevy LS7 454s. Those big block engines developed 465 horses each, but the carts were still referred to as Buicks. In the 80s, the AG330s were mothballed, and a pneumatic air starting system was installed on the SR-71. Sure, the start carts were hard to maneuver, and logistically, if a Blackbird landed at another base, starting it was a whole lot easier with the pneumatic system, but it just wasn't the same without those big monsters roaring to life each time a J-58 kicked off. No matter how cool the engines, the Buick, and the tires are, there is still one thing we haven't seen: the office. What's a tour without a look at where the magic happens? You know what? We're doing this. Oh man, this is what I have been waiting for. Holy cow, I'm in an SR-71. This is so cool. You know what? It's smaller than I expected. It's also a little less techy than I thought it would be. There are no big screens or anything like that in here. This is all analog, baby. Here's the attitude indicator, or artificial horizon. It's pretty standard stuff. Every plane has one, so, no biggie. But this This is a pretty important instrument. It's the airspeed indicator, which is great until you get to Mach 2 and above. Then you use the instrument over here. That's the TDI, or Triple Display Indicator. It tells you your knots equivalent airspeed, altitude, and Mach number. Here are the fuel flow gauges that read in thousands of pounds per hour. At normal cruise, these read about 21,000 pounds per hour. That is a lot of JP7. This bigger dial is the actual fuel gauge, which shows up to 70,000 pounds of fuel. That is crazy. Speaking of fuel, these rectangular lights represent the 6 fuel tanks in the aircraft. They are numbered 1 through 6 from the front of the aircraft to the back. As the aircraft uses up fuel, the center of gravity changes, so the pilot could transfer fuel forward by pressing this switch to maintain a good center of gravity. You could also transfer fuel aft, but that switch you had to hold down so you wouldn't forget about it. How smart is that? These are the go-fast handles. Some pilots call them throttles, but I like my name better. Did you know that the Blackbird cruised in full burner? No wonder this thing drank gas. Remember we talked about TEB when we were checking out the Buick? Well, these little bubbas are the TEB counters. You had 16 shots of TEB during your takeoff and flight, and these guys counted them down for you. Okay, that pretty much does it for the front office. Before we check out the launch control officer's cockpit, let's talk to Les and John again.
I was fortunate. Very, very few, problems with the airplane. Landed away once or twice during training sorties in the States due to one was a hydraulic problem, one was an electrical problem. Relatively minor, but the checklist said you will land at the closest suitable base. And probably the worst thing I had happen to me operationally was the tanker aircraft moved its track without us getting the word. So once we start down, we are committed to popping out at 27,000 feet or a like altitude at a certain point and having the tanker 5 or 6 miles in front of us at the most. And we leveled off and getting a little critical on fuel already, and the tanker's 120 miles in front of us. And we're floating along at 0.9 Mach and eating fuel up just as fast as we possibly can. When we finally connected, it was a big sigh of relief. Big sigh of relief. And not a lot of gas left.
My experience over 4.5 years was similar to Les's. Generally, airplane's very faithful. A couple hydraulic failures, never landed away. I did have one unstart experience, which I'll never forget. An unstart is a particular event that's unique to a turbo ramjet powered aircraft like the SR was. And what it basically means is that the shock wave that's captured inside the nacelle of the engines gets spit out, and for various reasons. And that does 2 really bad things to you at the same time. 1, you lose a lot of thrust, and 2, you have a lot of drag on that side of the airplane. So the airplane tends to make a hard yawing motion one way or the other. And as the story goes, the airplane often meets your helmet on one side or the other. And the airplane rapidly can lose altitude and so forth. It was much less common in the era I flew because the airplane had been converted over to digital computers at that point. The airplane was getting more and more efficient because of the computerization, the digital computers we had now running the fuel control and the inlets and so forth. But I'll never forget that. And that's the instance where my pilot had both his hands on the stick, pushing full forward to keep the nose from coming up and the airplane flipping itself over and breaking up.
I'm back in the rear cockpit, and this is a great time to talk about our aircraft. If you've not gone to sleep yet, you have heard me refer to the plane as an A12 and not the SR-71. Well, that's because our aircraft isn't an SR-71. Heck, it's not even an A-12. It's actually one of the rarest birds in the A-12 SR-71 stable. Ours is an M-21. They only made 2 of them, and ours is the only one left. That means that we are looking at some pretty rare stuff right now. How cool is that? Oh, and the M in M-21 stands for mother, and the D in D-21 stands for daughter. That's also really cool. All right, anyway, the M-21 was one of the few skunkwork projects that was relatively unsuccessful. The M-21 was designed to launch the ultra-secret D-21 drone. After Francis Gary Powers was shot down over Russia in 1960, the United States began looking for a way to end manned flights over the country. Kelly Johnson came up with the idea of using an unmanned drone that would be launched from the back of a modified A-12 and use the same engine technology. Under the codename Tagboard, 2 A-12s, 60-6940 and 60-6941, were modified with a second cockpit for the launch control officer, which is where I am right now. And a large pylon on the aircraft's back that supported the D-21 supersonic drone is right back there. The first flight of the D-21 M-21 combo was made 3 days before Christmas in 1964, and the first launch from an M-21 occurred in 1966. 3 successful launches took place, but on the 4th, the flight profile was changed just a bit. For the first 3 launches, the drone was released from the M-21 while it was in a parabolic arc. This allowed inertia to pull the drone away from the mothership. However, on that 4th launch, the release was during straight and level flight. As the drone released from the mothership, 6941, it struck the M-21, causing it to break apart. The 2 crew ejected, landing in the sea. The pilot, Bill Park, survived, but tragically, the launch control officer, Ray Torick, drowned when his pressure suit filled with water. The crash ended all further M-21 flights, and the D-21 was modified to be launched from an ultra-modified B-52H Stratofortress. Now, our plane, 6940, never launched a D-21 drone, and it flew just 80 missions, most of them ferrying drones from one place to another, or as a chase plane for 6941. It racked up about 123 hours and is the Blackbird with the fewest hours in the fleet. That means this lady is pristine. Now I know what you're thinking. How did the museum get this really rare and super cool plane? Well, our bird came to us in 1991 after years of behind-the-scenes discussions with the Air Force. And in 1990, the Blackbird was retired by the U.S. and we were offered the M-21. We couldn't say no. The problem then became getting it from Mojave, California to Seattle. Luckily, when you have to move a Blackbird, people want to help. Volunteers and museum staff members dismantled the plane and it was trucked north on 5 semi-trailers. It took 12 days to make the trip here, but when the bird rolled into the parking lot on September 17, 1991, it was one heck of a party. But now we got to put it all back together again, and it wasn't until 1994 that we added the D-21 drone, but it was certainly worth the time and effort, you know? Ooh, you know it's a long video when your hair grows back into your head instead of to your shoulders. This has been awesome. How many times do you get to look into the cockpit of an actual Blackbird? I am on cloud 9 right now. This is crazy cool, and I have had a blast doing it, and I'm so glad that all of you are tuning in and watching. Thank you so much. And remember, if you've got questions or comments, make sure to hit us up on YouTube, our Facebook page, or shoot me an email at curator@museumofflight.org. Stick around, we'll have more videos to come.